Okay, these are some homework problems from section 4.3, and we just want to find the relative extrema. So first thing we do is we take our derivative of our function. We get y prime equals 2x minus 1. Well, it's a straight line. We don't have to worry about it being undefined. It's not undefined, but it's 0 when x equals 1/2. So that's my critical point. Remember, whenever the derivative is either equal to 0 or undefined, that's a critical point, and that's where your relative extrema are going to happen. So at x equals 1/2, so I put x equals 1/2 in here, and I double check. Or I check to the left, I can try 0, that's to the left of 1/2. If I put 0 in my derivative, I get a negative. 2 times 0 is 0, negative. Right there. And if I put 1 in there, 2 times 1 is 2, minus 1 is positive. So it looks like my derivative is negative here, which means my function is decreasing. And my derivative is positive here, which means the function is increasing. So it looks like I've got a relative, since the function is decreasing and then increasing. It looks like I have a relative minimum. I want to find the y value, so I have to put the critical point into the original function. So 1/2 squared minus 1/2 minus 1, which is 1/4. 1/2 is 2/4. 1 is 4/4. So negative 6/4 plus 1/4 is negative 5/4. So that's my y coordinate at the critical point. So I have 1/2 negative 5/4 is a relative minimum because y prime changes from negative to positive there. Now, since it's a parabola, and we know it's going to be shaped like a U, then we could also say that it's also an absolute minimum. So this is also an absolute minimum. But we're primarily concerned with the relative. Okay, let's take a look at number 3. There's a little bit more going on with this one, because we have a 4th degree equation. Now you have to remember from a little bit of your trig on this stuff, so hopefully this will carry through here. Just get this squared away here. Okay, this should be, I think you can see it all there. Okay, should be also. Okay, so this is what we've got. This is number 3. So just a little bit more. There we go. Okay, I hope you can see this. Maybe we'll get down and zoom down a little bit more into this. I think that's better. Okay, so this is my 4th degree equation. Now remember, 4th degree equations are, they're going to look at the end behavior, so this is going to start positive, end positive. And lots of times they have the characteristic being shaped like a W. So be aware of that. Since they go up, they kind of go up like parabolas, they go up to the top. So they don't have any absolute maximums, but they could have some absolute minimums, so be aware of that. Okay? Kind of remember that from your pre-calculus days of graphing those things. So if we want to find the extrema, we'll take the derivative of this 4th degree equation. And y prime is going to be 8x cubed minus 8x. And remember, this is a nice cubic. It's not going to be undefined. There's no discontinuities. But it will be equal to 0 whenever we set this equal to 0. We can factor out the 8x. And we've got 8x times, and that's going to be x squared minus 1. So 8x, x plus 1, x minus 1. So this equals 0 when x is either equal to 0, 1, or negative 1. So those are going to be the values of x that give me my critical points. So I'll put these into my first derivative test, y prime. And there's a lot going on here, so I hope it's not too cluttered, but these are the critical points: negative 1, 0, and 1. Negative 1, 0, and 1. So those are right there. I hope you can see that. Got a lot going on here. And then I tried some values here. So when y prime was negative 2, so if I put negative 2 in here. Now what I did over here was I looked at the factors. I didn't really want to worry too much about the exact values. But if you put negative 2 in here, that's a negative. If you put negative 2 in there, you get a negative. If you put negative 2 in there, you get a negative. So a negative times a negative times a negative is a negative. So I just have to worry about the signs. And then when I tried negative 1/2, this would be negative, but negative 1/2 plus 1 is positive, and negative 1/2 and negative 1 is negative, so I have a negative, positive, negative, which ends up being a positive. And then I could try y prime at 1/2. If I put a 1/2 here, I'm going to get positive, positive, and negative. 1/2 minus 1 is negative, so I have negative. And then if I put 2 in here, this is positive, 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 so I have positive. So since my derivative is negative, my function is decreasing. Since my derivative is positive, it's increasing. Negative, decreasing, positive, increasing. Okay, so here we have at negative 1, and then I put the values back in the original function, and that wasn't too hard. If I put negative 1 in here, this is going to be positive. I mean, this is an even function, so it's going to change that to a positive number. Positive 1, so I just have 2 plus 1 is 3, minus 4 is negative 1. So if I put negative 1 in for x, I get negative 1. If I put 1 in for x, I also get negative 1. Okay? And these are where I have a relative minimum. You can see at negative 1 and at 1, we're going from decreasing to increasing, from decreasing to increasing. So we have relative minimums here. So we could say that the points negative 1, and 1, negative 1 are relative minimum because y prime changes from negative to positive there. Okay? And then this point here is 0, and then if I put 0 in here, I get just 1. So the point 0, 1, those are easy to substitute. I'm changing from positive to negative or increasing to decreasing. So the point 0, 1 is a relative maximum because y prime changes from positive to negative there. So my function is going like this, and like I said, it sometimes looks like a W, and this is what it does. It looks like a W. All right? So it's not going to go beyond these points. It's just going to come down to these points, go back up to, it's going to actually go up to 0. So it'll be very easy to sketch this graph, actually, because you could put these points in. And you know it's going to start up or high. So in reality, because it's going to dip down just to here, and these are relative minimum, these are the only relative minimum, they are also absolute maximum. So the point negative 1, and 1, negative 1, since they're both a low of negative 1, that's as low as the graph goes, those are both also absolute minimum values. And like I said, if you sketch it, it would be pretty easy to sketch. Actually, you could put these on your graph, and then it would come down to here, somewhere in there, it'd go up at 0, back down, something like that. And you can check that on your calculators, and you'll see it's a W, and those are the minimum points. Okay. So I hope that helps you out on that one.